Let's take a look at using transformations to sketch the graph of f of x equals x squared and g of x equals -2 times the square of x minus 3 plus 1. Please note the sign changes. I've changed, if you pick this hand up in class, I changed the plus 3 to a -3 and the -1 to a +1. All right, so let's take a look at the parent graph f of x equals x squared. Notice that's your generic vertical opening, upward opening parabola whose vertex is at the origin. All right, and we want to look at the fact that the +1 in g of x is actually a vertical shift. Notice that if I have the function y equal f of x plus c, and c is a positive number, that is a vertical shift c units upward. If I have y equal f of x minus c, that's a vertical shift c units downward. So notice how if I employ this vertical shift, notice the red solid curve, every point on the blue dash curve has been moved 1 unit upward. And so notice y, the red curve, is actually the graph of y equal x squared plus 1. So when I look at the function g of x equal -2 times the square of x minus 3 plus 1, notice I'm putting that in red to show that the effect that has is what I see on this red curve. G of x shifts f of x 1 unit upward. And notice that we could think of g of x as -2 times f of x minus 3 plus 1. All right, so that +1 is a shift in the graph 1 unit upward. Now let's look at the role the -3 plays. And we could, again, think of this as g of x equals -2 times f of x minus 3 plus 1. If c is a positive number, and I change my input from x to x minus c, that's a shift c units to the right. If I change my input from x to x plus c, and c is positive, that's a shift c units to the left. In our case, we have a right shift by 3 units. So g of x has shifted f of x 1 unit up, 3 units right. So let's take a look at what we see if we only employ those two transformations. So notice I've put the -3 in green, color coding this, which corresponds to the green solid graph that you see on the left. So the red +1 gave me the red dash graph. The blue dash graph is the parent graph, f of x equals x squared. The red dash graph is what happens when the graph is shifted 1 unit up. And now the green solid graph is what happens when I also shift the graph 3 units to the right. So I've employed 2 of the transformations. Now let's look at what happens when I employ the minus sign that's in the problem. So this is a reflection. The graph of y equal -f of x is obtained by reflecting the graph of y equal f of x about the x-axis. The graph of y equal f of minus x, so if you change the input by multiplying it by a minus, you reflect y equal f of x about the y-axis. We're reflecting about the x-axis. So notice I've shifted 1 unit up, that's the red +1. 3 units right, that's the green, minus 3. And now I'm reflecting about the x-axis, and that's a purple, minus 2. Technically, because I've actually shifted the graph up, I'm really going to be reflecting about the horizontal line that's 1 unit above the x-axis. But the main point is that that negative sign causes the parabola to open downward. So g of x now has performed 3 transformations on f of x. And let's look at what those are. So g of x shifts f of x 1 unit up. That's the effect of the plus 1. Also, it shifts it 3 units right. That's the effect of the green, minus 3. And notice that was employed in the green dash graph. And then what we are talking about now is that g of x has reflected f of x about the x-axis. So that's the purple downward opening graph that's solid. That's what we're dealing with now. So that's our most recent change. Now let's talk about vertical stretches. Remember, if I multiply f of x by a, the graph y equal a times f of x is a vertical stretch if a is bigger than 1. It's a vertical compression if a is between 0 and 1. And so one way to think about a vertical stretch is to think about your body. If you get 6 inches taller and you don't gain any weight, you're going to be skinnier. So a vertical stretch makes the graph skinnier, narrower. If you get 6 inches shorter and there's no change in your weight, you're going to be fatter or wider. And that's what a vertical compression does. It makes a graph wider. So let's take a look at g of x when we employ all of the transformations. So notice we've shifted 1 unit, f of x 1 unit up, 3 units right. We've reflected about the x-axis. And now we're going to stretch f of x vertically by a factor of 2. And so let's look at what the picture of this looks like. Remember, that's like you all of a sudden becoming taller and no change in your weight. You're going to be thinner, skinnier. So notice how the graph is downward opening and much thinner than the previous pictures. And notice all of the previous transformations are dashed. I started off with the dashed blue graph. I shifted 1 unit up, 3 units right, and reflected f of x about the x-axis and stretched f of x vertically by a factor of 2 units. And so what do I wind up with when I perform all of those transformations? I wind up with the orange solid graph that you see. But notice the transformations that occurred. The blue graph is the original f of x equal x squared. The red dash graph is the upward shift, vertical shift upward. The green is the horizontal shift to 3 units to the right. The purple dash graph, downward opening, is the effect of the reflection, the negative sign. And then finally, the vertical stretch by a factor of 2 units gives me my final solid orange graph.